All right, ladies and gentlemen, we are on to section 4.4, 4.5 notes, day 2. If we're looking at example 1, ask us, what if the hypotenuse and one leg in a triangle are congruent to the corresponding hypotenuse and leg in another triangle? Are the triangles congruent? And so if we look at our proof here, or if we look at our figure that's given here, we can see that in our first figure that we have the triangles separated, and then in our second figure that we have the triangles together, and that's going to be helpful as we go to do our steps of our proof here. So if we look at the first piece of information, it says that angle MAH and angle TAH are right angles. And so if we look at that angle MAH and angle TAH, those markings are given to us, and so that reason is given. If we look next, then it says that angle MAT is congruent to angle TAH, and because they are right angles, we know that all right angles are congruent. So we have an angle, that we have angles that are congruent to each other. And then if we look at this piece of information here, we have MH, which is this side here, congruent to TH, which is this side here, and that information was also given to us over here. Now, from that information, we know that what we can have is that if we have two sides that are congruent in a triangle, that we are then able to say that angle M is congruent to angle T, which is our isosceles triangle theorem, which we know that if we have two sides that are congruent, that those base angles must be congruent. And so then we are now able to say that triangle MHA is congruent to triangle THA, and that is by angle, side. And so if we look at that, it is by, there's our angle to angle, angle to angle, side to side. So therefore, our conclusion, if the hypotenuse and one leg in a triangle are congruent to the corresponding hypotenuse and leg in another triangle, then the triangles are congruent. Okay, we call this hypotenuse leg, which we just abbreviate HL. All right, so let's take a look at what is given here and what we want to prove. And so what we have is an overlapping triangle. And sometimes it's helpful if we pull those two triangles out, and that helps us to see the two separate triangles. So if you look here, you can see that what we're trying to prove is that triangle HIL is congruent to triangle PIE. And so if I look at HIL, that is HIL, and we're trying to have it congruent to PIE. Okay, and so as we go through, we're going to try to see where we need to do our markings. We might need to do them here on the overlapping or here on our words that are broken apart. The other thing I want to put in is that right here is going to be angle 2, and right here is going to be angle 1, so that we have that information in there. Okay, so if we look, the first one, angle 1 is congruent to angle 2, and that is given information. And so we know that angle 1 is congruent to angle 2. And then we have angle IHP is congruent to angle IPH. And that is also by given information. And so IHP is congruent to IPH. And so these are these angles that are over here, these big angles. IHP is this angle here, and it is congruent to IPH, which is this angle here. Now, if we look at this large triangle here, we know that if we have these angles, these base angles that are congruent, then these sides must be congruent. So we're going to be able to say that this side here, which is segment HI, is congruent to this segment here, which is segment PI. And our reasoning behind that is that if we have base angles that are congruent, then that implies that the sides opposite are congruent. We then know that that we have an angle that is shared up here. We can see that angle I is here, but angle I is also here. And so if we look at that, we're going to be able to say that let me erase that. That angle I is congruent to itself, angle I, and that is the reflexive property. Now, if we go to look at what we have as far as our triangles go, we now can say that these two triangles are congruent because if we have an angle congruent, and a side congruent.